Hello and welcome to Astronomy Daily, your source for the latest developments in space science and astronomy. I'm your host, Anna, and today we've got a fascinating lineup of cosmic news to share with you. We'll start with a surprising revelation about our galactic neighborhood. Then we'll look at how robots could revolutionize space-based solar power, with breakthrough technology that might soon beam constant clean energy back to Earth. We'll also examine why June's upcoming full moon will be sitting unusually low in the northern sky, a rare celestial event. And finally, we'll catch up on the latest launches from SpaceX and Rocket Lab, including historic milestones for human spaceflight. So stay with us as we journey through today's cosmic headlines on Astronomy Daily. Let's kick things off today with a story that might help you sleep easier at night. For what seems like billions of years, astronomers have been telling us that our Milky Way galaxy is on an inevitable collision course with our nearest large galactic neighbor, Andromeda. This cosmic crash was thought to be about 4 to 5 billion years in our future, with the merger eventually creating what scientists had already named Milkomeda. But now, this long-held belief is being challenged by new research. A paper published in Nature Astronomy suggests that this galactic collision might not be as certain as we once thought. Scientists have analyzed the latest and most accurate observations from both the Gaia and Hubble space telescopes, combined with recent mass estimates, to recalculate the possible future scenarios for our local group of galaxies over the next 10 billion years. The Milky Way's path through the universe isn't just influenced by Andromeda. It's actually affected by the gravitational pull of several objects in our cosmic neighborhood, including the smaller Triangulum galaxy, also known as Messier 33, along with the large and small Magellanic Clouds and various superclusters. What's particularly interesting is how these other cosmic bodies play a significant role in determining whether the Milky Way and Andromeda will actually collide. The research shows that while the Triangulum galaxy increases the merger probability, the Large Magellanic Cloud's orbit runs perpendicular to the Milky Way-Andromeda path, which actually makes their merger less likely. The most striking finding from these new simulations is that there's nearly a 50% chance that the Milky Way and Andromeda won't collide at all within the next 10 billion years. That's a dramatic shift from what was previously considered almost inevitable. The researchers do acknowledge some uncertainties in their model. They assumed, for example, that the mass distributions within the galaxies remain constant over the next 10 billion years, which may not be entirely accurate. But their updated simulations, using the latest observational data and physics, cast considerable doubt on whether this cosmic collision will ever occur. Interestingly, the study suggests there's a higher chance that the Milky Way will actually collide with the Large Magellanic Cloud in about 2 billion years. Of course, none of us will be around to witness any of these potential cosmic crashes, but it's fascinating how our understanding of even the largest scale events in our cosmic neighborhood continues to evolve. Next today, and I assure this is real and not some fancy sci-fi dream. In a breakthrough that could revolutionize clean energy production, the UK Atomic Energy Agency has demonstrated that remotely operated robots can successfully build gigawatt-scale solar power satellites without human intervention. This development, part of the Albatross project in collaboration with clean tech firm Space Solar, marks a significant step toward achieving round-the-clock renewable energy from space. The project, based at the UK AEA's Culham campus in Oxfordshire, utilized dual-arm robotic manipulators to construct satellite components designed to be several kilometers long and about 20 meters wide. This robotic approach offers both cost advantages and safety benefits, by reducing the need for astronaut involvement in the assembly, maintenance, and eventual decommissioning of these massive structures. What makes this concept particularly promising is the intensity of solar energy available in space. According to the European Space Agency, sunlight at the top of Earth's atmosphere is more than 10 times stronger than at ground level. These orbital solar collectors would capture this uninterrupted energy source and beam it back to Earth as microwaves, which could then be converted into electricity by ground-based antennas. The robotic technology being developed at UK AEA's Remote Applications and Challenging Environment Center isn't just for space applications. These same innovations support fusion energy production on Earth, highlighting the synergy between terrestrial and space-based energy solutions. Space Solar is moving quickly with this technology, expecting to commission its first 30 megawatt demonstrator system by 2029 and reach full gigawatt scale capacity within the following decade, potentially providing a continuous stream of clean energy from the limitless solar resources available in orbit. If you've been watching the night sky, you might notice something unusual happening this June. The full moon on June 11th, 2025, will appear remarkably low in the sky for Northern Hemisphere observers. In fact, it will be the lowest full moon we've seen in decades. This isn't random chance or an astronomical anomaly. It's actually part of a fascinating 18.6-year cycle that affects how we see our lunar companion. Unlike what many people assume, the moon's orbit isn't aligned with Earth's equator or even with Earth's path around the sun. The moon's orbit is actually tilted by about 5.15 degrees relative to the ecliptic. That's the plane of Earth's orbit around the sun. This tilt, combined with Earth's own 23.5-degree axial tilt, creates some interesting effects that play out over long time periods. Because of these combined tilts, the moon can appear anywhere from 28.65 degrees south to 28.65 degrees north in our sky. This means that over time, the moon seems to wander north and south against the background stars. Astronomers call the extreme points in this cycle lunar standstills. The last major lunar standstill occurred in 2006, and now we're approaching another one. During this period, the moon's path swings to its maximum extremes, making it appear exceptionally high in winter and exceptionally low in summer for Northern Hemisphere observers. That's why this June's full moon will barely skim the treetops for many North American and European viewers. And if you're in places like Alaska or Iceland, the moon might not rise at all. Meanwhile, observers in the Southern Hemisphere will experience the opposite effect. They'll see what's essentially their own long night's moon, riding remarkably high in their June skies. This gradual shifting of the moon's path happens because the moon's orbital plane is slowly being dragged around once every 18.6 years, primarily due to the gravitational pull of the sun. Astronomers call this the nodal precession. What's particularly fascinating is that ancient peoples recognized and tracked these lunar cycles. At the Callanish stones in Scotland, erected during the Bronze Age over 4,000 years ago, archaeoastronomers have discovered alignments that mark the rising and setting positions of the moon at its extreme standstills. These ancient stone circles served as astronomical calendars, helping people track longer periods of time than the regular monthly lunar cycle. So when you look at this unusually low full moon in June, remember you're witnessing the same celestial mechanics that our ancestors observed and celebrated thousands of years ago. A living connection to humanity's earliest attempts to understand the rhythms of the cosmos. Let's switch gears now and look at what's happening in space launches this week. SpaceX continues to dominate the launch schedule with an impressive 5 missions packed into just 1 week. Rocket Lab kicked things off with their 65th Electron launch, nicknamed Full Stream Ahead. Just before June 3rd ended in New Zealand time, they successfully deployed a Black Sky Generation 3 satellite into orbit. This marks Rocket Lab's 10th launch for Black Sky technology, making them the most frequent launch provider for this constellation. The Gen 3 satellites are quite impressive, capable of producing images with 50-centimeter resolution and equipped with shortwave infrared sensors. SpaceX has been even busier with multiple Starlink deployments across different launch sites. From Cape Canaveral in Florida, they launched Starlink Group 1219, carrying 23 Starlink V2 mini satellites, 13 of which feature the new direct-to-cell capabilities. This mission used booster B1077, making its remarkable 21st flight. The very same day, SpaceX conducted another Starlink launch from Vandenberg Space Force Base in California, delivering 27 more satellites to a different orbital inclination. And if that wasn't enough, they scheduled yet another Starlink mission for June 8th from Vandenberg, adding 26 more satellites to their rapidly growing constellation. Beyond Starlink, SpaceX is launching the SXM-10 satellite for SiriusXM on June 7th. This third-generation satellite weighs over 6,000 kilograms and will replace older satellites in the constellation that have been in service since 2005 and 2006. SiriusXM currently serves over 33 million subscribers, highlighting how space technology directly impacts everyday services many of us use. Perhaps most exciting is the Axiom 4 crewed mission launching June 9th. Commander Peggy Whitson will lead a diverse international crew, including Shubhanshu Shukla from India, Slavoj Uznansky from Poland, and Tibor Kapu from Hungary, each representing only the second astronaut from their respective countries to reach space. They'll spend up to 2 weeks aboard the International Space Station conducting 60 scientific experiments, setting a record for the most research activities during an Axiom mission. The Dragon capsule for this mission is brand new, making its first flight, while the Falcon 9 booster is flying for just its second time, having been used only 41 days earlier for a Starlink mission. These milestones highlight how commercial space missions are now creating opportunities for nations that don't have their own human spaceflight programs to send their citizens to orbit. It's democratizing access to space in ways we couldn't have imagined even a decade ago. Well, what an incredible journey through space we've taken today. From reconsidering the collision course of galaxies to robots building solar satellites in orbit, from the moon's fascinating dance across our skies, to the remarkable diversity of launches carrying humans and technology beyond our atmosphere. I'm Anna, and I want to thank you for joining me on this episode of Astronomy Daily. If you enjoyed today's cosmic update, please visit astronomydaily.io, where you can sign up for our free daily newsletter, delivering the latest space news right to your inbox. Don't miss future episodes by subscribing to the podcast on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. Your support helps us continue bringing the wonders of the universe down to Earth. Until next time, keep looking up. There's always something fascinating happening in our cosmic neighborhood.